Welcome to today's episode of Pipeline Things. I'm so glad you joined us today. Christopher is back from vacation and he's in a good mood.
Yeah.
He's relaxed.
Very.
We talked about geometry tools and deformation tools. And if you are already like, oh my gosh, I'm not interested, it's because geometry tools are like the middle child, and I'm sensitive.
And they need a lot of attention.
We need attention. You need to listen to this episode. No, seriously, if you've ever struggled with questions around validation, different types of geometry tools, what you can get reported, the difference between wrinkles, ripples, and buckles, this is a good episode for you. Hope you listen, and thanks for joining us. Do it, yeah. I don't know what this is. We're totally botching it here today. Welcome to today's episode of Pipeline Things. I am your host, Thing 20, otherwise known as Rhett Dotson. My co-host, Thing 21, is back.
Finally.
Christopher, I know. So the audience catches us like every 2 weeks, so they don't realize how long we've been apart,
away from each other. Yeah.
This is actually the first day that we've been able to work together.
It's a full day together.
It was a full day.
It's been like 15 days if you think about it.
Right. We're probably worn out. We're probably going to wear out this producer by the time we're done with it. So where you been, man?
We went through a couple of states. So have you ever made the drive to the Panhandle of Florida?
Yeah, it's a beautiful place.
It is really nice. So we found this nice little niche between Destin and Seaside called Miramar. It's awesome.
It's a niche?
Well, I like it. It's like a little. I feel like most people pass through it. People will either go to Seaside or they'll go to Destin, but they don't really stop in Miramar. We decided to stop. It's awesome. Don't go there. Y'all go to the other places.
Yes. Don't take Chris's advice. Go to the other places if you're listening. Well, buddy, I have to say, it's so good to have you back. I feel like I don't want to be salty, but it felt salty while you were gone.
Really?
Yeah.
Well, I will tell you this. It's always interesting when you're doing a road trip with your family because you can tell. I have 3 kids, if y'all don't know. And you can always...
I grew up as one of 3, just for the record.
And so like, all of your kids' personality traits come out on a road trip. And so if you've ever driven from Houston, relatively, to Destin, relatively... Depending on your family and the size of it, it's between 10 and 12 hours.
Yeah.
Mine is a 12-hour drive all the way. And so back to you see all your kids' personality. So one of them, like my oldest, she's very inquisitive. And so every time we pass a billboard, guess what she asks? Hey, Dad, can we stop there?
That could be problematic.
Or, hey, Dad, what's that billboard? So you want to get through Louisiana as fast as possible.
Sometimes downtown Houston, that can get real awkward real quick.
But anyways, and so what's really funny...
I've got visions in my head of your daughter asking you questions that you don't want to answer now. And it's like, how do you deal with that? So, Dad, what is the lion's den? Anyway.
And
everybody that has gone through Louisiana
knows
that.
about the
They know what. Yes, they get it.
Anyways,
this producer clearly has it because she's like,
and she's like, "What is this?"
About? Don't.
It's the casinos. Maybe
Look,
she's heard of those.
No, do not Google that on a work computer. That's all I'm saying. We'll tell you after the show.
But and really, what the highlight was Juliet. So Juliet is, you would imagine, youthful.
She's your second, right?
She's my second, and she's the life of the party. She commands attention, and when you don't give her the attention, that person.
What? That person? Did you bite your tongue?
You're a middle child, aren't you? This is all beginning to make sense. Oh my God, you are a middle child.
I am a middle child. Look, if you are about to look, I don't know that I'm a protected class yet, but middle child syndrome's a real thing. And if that's where you're going, Miss Producer might have to stop the show because I might get kind of hot. Middle child, like, you don't understand. You're not a middle child.
Well, it depends. I kind of am. Well, that's another subject for another day.
Okay.
Anyway,
I was a genuine middle child, sandwiched between an older brother.
That's what I'm saying.
Okay, we got to get real here.
I have an older sister and a younger brother, but we didn't all 3 live in the same house, which is what I'm saying.
Oh, see, we did.
Yeah, that's what I'm saying.
I bumped with my brother. And no, you got to understand something. We got to get real with the audience here now. Because I grew up, and my brother was 3.5 years older than me, so he was a senior when I was a freshman.
Beating you up, is what you're saying?
No, he actually looked out for me. My brother was really good.
Okay.
God, I hope people don't start Googling my brother now. But
he's gonna get all these friend requests on LinkedIn.
Oh, gosh. What was funny is, so my brother was actually considered really good looking in high school. And he was like Mr. Popular. He was voted Mr. Sanimal. Like out of a school of 400. Wow. This is my brother, right?
So that bus just drove right by.
Yeah, imagine. I opened myself up. This is why I don't get vulnerable on the show anymore. As a freshman in high school, I walk in my first week. Yeah. And my brother's a senior, right? And so I'm kind of like the awkward freshman kid. This actually goes along with the beginning of school right now, right? Yeah. And this girl walks up and she's like, "Oh, you're Travis Dotson's little brother?" She's like, "Oh, he is so hot." And I'm like, and then she just walks right on. Yes. Like, I got no mention of the being
everybody
hot
needs. So, were you a good wingman or not? I mean, that sounds like an opportunity.
No, I was too young to be a wingman.
I like this
being middle child. Look, dude. So it's real. You get looked over.
So today's episode, and I know you like to take the reins on this. We're going to talk about another ILI technology, and I feel like it is totally appropriate to bring those two things together.
Oh, you're going to change our okay? Good,
the idea of middle child syndrome, the middle child, and wingman. How there was a lot of opportunities there, bud. Maybe the opportunities weren't taken advantage of. So, what are we going to talk about today, Rhett?
So, I guess, now we'll let the audience in. Now, I'm curious. So, we're going to freeform this puppy and go with the middle child thing. Let's do it. Today's topic is geometry tools, right? So, we've covered a couple of other technologies with the audience. Geometry is one that I've actually been waiting to do for a while because I am very partial, have real strong ties to geometry, but it doesn't always feel that way in the industry. Yeah. You just kind of like, going back to the thing, people are like, "It's EMAT, you're so hot!" And the geometry tool's like, "I'm here.
I can be helpful too."
Yeah, I can be helpful too. That's really good, right? So we've talked about EMAT. We've talked about IMU. Today's geometry, right? So I think
MFL. We did quite a bit on MFL.
We talked about
MFLA and stuff like that.
We talked about who's going to lead this one. And I think it's going to be interesting because for the audience, I think you're going to get a mixture of both here. My first exposure to ILI was really on the geometry side of things, going back to my days as a consultant before I was at Rosen. And I got pulled into a lot of dent work. So my first exposure with ILI tools was really on the assessment side, getting data from vendors, running into issues, and seeing some of the challenges that come up, but usually from clients seeking help from me as a consultant. Yeah. You experienced it on the operator side, so I think you're going to see us kind of both bringing some perspectives to the table here.
And also, I mean, it's fair to bring up, when you work for an ILI service company, especially a very large one like Rosen is, right? Call it what it is. I mean, they're huge, and their fleet size is just, it's awesome, right? Lots of different options there. They're not the only ones, obviously, but so there is a process in understanding that not all geometry tools are the same. Yeah. They deploy similar type technologies, but some have a little bit more, some have a little bit less. And so I think maybe we can spend some time today thinking about what are those different technologies.
We always start with the beginning, right? Where the tools begin, Chris. And it's interesting because it's funny, you went with the different sensor technologies. Mm-hmm. The most common question, the most common way, I think, is people try to divide them between high resolution and standard resolution. But I'm going to be honest with you. Yeah. I don't think we want to do that here. And there's a reason why. Because, look, we know the ILI vendor market, right? Yep. Everybody's tool is high resolution. Right, whatever they mean by that can be something totally different. But the high resolution tag is not a good way to divide it. I think we go back to the different sensor types.
And we need a caveat there though. Every time we talk about ILI tools and ILI technology, I always like to say it's really important to understand what our objective is. Like, what are you trying to accomplish? You have to understand that. Because there is a pretty decent market and a clear use for maybe not high resolution tools and highly sensitive tools, right? And I think we could actually use that as a little bit of a segue into like one of the first tools. So one example of that would be you could only have 8 channels, but each channel sits behind a cup. And so you're still getting full circumference, so it's highly sensitive to geometry changes. It's just not high resolution. Right. And there's a big market for that. Like, for example, post-construction pre-commissioning inspections.
Oh, right? Boy. See, you're hitting on so many things, though, that we got to get rid of. So, number one, number of sensors is not a good metric, because 8 sensors in a 16-inch pipe is terrible resolution. 8 sensors in a 4-inch pipe would actually be about the best resolution you're going to get. So I think my first feedback on that is, number one, don't focus on the sensors. But you did focus on the deployment of the sensors. And I do think it's worth noting that they come in different forms, right? So you do have some that are behind the cup. Those are usually suitable for detection and location.
High sensitivity.
They're usually going to be very challenged to give you the data you need to do any type of an advanced assessment. So that does go back to your objectives. Do you just want to find it?
Let's call it what it is, right? So, you know me, I like to be real disciplined about POD, POI, and sizing. Right, so let's just go with that. Let's say 16-inch line, just as an example, 8 sensors, but they're behind cups. Behind cups means it still covers the full circumference. It'll do a really good job at detecting geometry defects.
Yes, it will.
It'll do a good job of identifying them as geometry defects, because it's still writing and you're getting the deformation full circumference. And it'll probably size it pretty well too. What we don't know is maybe the circumferential width of it, because of the resolution, right? And so it's just a way to think through things, right?
Right, and I think those are the important questions to ask, right? There are a lot of times where that configuration suits your needs. You need to ask the right questions. When you talk about resolution, if the vendor says, if you ask a vendor if it's high resolution, they're going to tell you yes, which is not helpful, right? You really need to understand what the sensor spacing is. You need to understand if you can get the data you need and perform advanced assessments with it, if that's your objective. But so you talked about some behind the cups. I feel like those are to some extent a little less common. I feel like it's more common now, especially among the majors, to see direct contact sensors, right? The contacts that traverse along the pipe, right? So they look like
often more called caliper tools. And maybe that's sometimes where you'll start seeing different namings, right? Deformation tool, or geometry tool, or caliper tool. Not that there is a clear distinction from all of them, vendor to vendor, but that's when you start kind of seeing some of those naming conventions come up.
And some of those will have the ability to handle, lift off might be one way they try and separate themselves from the market. But I'd say largely it's kind of behind the cup is one class, and then you have sensors that are in direct contact. In theory, though, they're all doing the same thing for our audience. You're hunting for geometric deformations in the pipe, bore restrictions, wrinkles, buckles, dents, anything that deform the shape of the pipe, ovalities. That's what you're hunting for with these tools.
And so if we think about, if we just take that to the next step a little bit, right? So if we talk a little bit about sensors behind the cup, high sensitivity, easy deployment, shorter tools, not as many electronics. The electronic package is simpler. You could almost say that's often used as like a screening tool. Like we said, obviously post-construction type inspections. When we think of these more direct contact, higher resolution, I feel like we normally want to associate those with integrity assessments. Right, and we say it because often if we look at like a lot of the reasons for these, it's you're performing an integrity system based on risk.
Now, let me ask. Oh man, are you going here on purpose because this is a hot button topic with me? Or are you just so you're trying to scratch an itch?
I'm trying to see how the middle child responds.
I'm gonna get irritable. That's the thing. So this is a hot button topic for me, Chris.
All right, go.
Here's the problem.
Get on your soapbox.
A pre-commissioning or a post-construction inspection does not have a different objective. I would argue should not have a different objective from your integrity assessment. It's an opportunity to serve as your first baseline assessment. Here is what I see happen all too often in the integrity market. Whoever builds the pipeline is responsible for doing the pre-commissioning / post-construction activities, and they target something that meets the commissioning objectives, which is usually to a much lower standard in terms of resolution and objectives than integrity assessments.
But it still can be used as an integrity assessment. You can still get credit for it.
Chris, oh boy, it's a struggle.
I'm just telling you what it is.
I'm telling you. So here's what I see happen. Whether you can use it as an integrity assessment or not, I won't dispute that. But here's what happens. And this is common. I can count probably not on two hands the number of times I've seen this happen. An operator runs a post-commission inspection, and I guarantee you there are operators listening that this is going to resonate with. We ran a post-commission inspection, and we got out all the dents that were greater than 2% because that's what our construction specs said. Then we ran the first tool, We ran our baseline inspection 2 years later.
Yep.
And we found insert number, X number of dents above 2%.
Yep.
Those were not new. They've always been there.
Yep.
You just didn't find them in the original inspection, or you didn't size them appropriately in the original inspection, or you didn't have the resolution.
Yeah.
I can go on down the line.
Yeah.
However that happens.
So, you know me now, I'll get on my soapbox a little bit. That's why it's really important when we think about inline inspection, almost independent of the objective, it's really important to understand this concept of an ILI system.
Mm-hmm.
It's not just about getting a tool that fits in your launcher that has X number of sensors. It's also the evaluation protocols and the experience of the analyst that's looking at the data.
Well, and it's understanding, right? So if you run that construction tool, and let's call it a construction tool, you run that construction tool and it finds a 1.8% dent, but you didn't report that.
Yeah.
Then you run the next tool and it's 2.1.
Yep.
Right. So it's again, if you're going to run that type of tool, considering what the reporting threshold, the accuracy of it is, because you likely need features that are below that. The other problem, and here's what happens. This happens so many times.
Yeah.
They get the dents. Inevitably, either the operator or the construction contractor doesn't want to dig the dents.
Yeah.
And they come to me and they say, I want to do a fitness for service assessment on these
Digs
dents.
cost money.
Right.
And so
then what happens?
That's great. Hold on. No, that's great. That gives them an opportunity to call us.
They ask for help.
And we can help them out because they're asking for help.
They ask for, but Chris, here's the problem.
Okay.
The data they got isn't good enough to perform fitness for service assessment.
Whoa. We have isn't good enough. I think we should be careful. What do you mean by good enough? It's poor quality.
Poor quality, yeah.
I thought you were going to go with sensor resolution to do a fitness for service.
Sensor resolution can be a component of that, right? Okay. So if I can't resolve the circumferential dimensions, can't do it. I've had some where the axial resolution, and that's the surprising one, isn't good enough to do a fitness for service assessment.
Yeah.
And I'm like, you had the opportunity, you had a tool in the line.
Yeah.
Just run this, like, in other words, let me summarize this for the operators.
Yeah.
Your specification for construction should be the same as your specification for integrity. That's my mantra.
Yeah. The challenge though they'll have there is the operational constraints and oftentimes timing.
Okay, right. So maybe you're running behind air, maybe you're doing some other things.
Yeah. There's just different reasons in how they'll apply. But the point is, I think it's a very valid takeaway.
As much as possible,
there is
they
value.
should match them up.
Yeah, there's value in understanding if the value prop in getting a direct contact, high resolution caliper tool into the pipeline is an option instead of a standard resolution or low resolution.
Now let me ask you a question now, because you got me on my little soapbox. I need to get off and flip it on you for a little bit here. I don't want to get hot on that. We'll probably get a comment from somebody that'll be upset, that I said that about construction or something like that. But I have been on the receiving end of that numerous times.
Yeah.
How many times, or what is your opinion or feel for using geometry-based tools for internal corrosion type assessments? Have you seen that? Let me ask you, have you seen that?
Yes, but you were talking outliers here, right? So if you look at a bell curve, if you're looking at the bell curve of all of the different applications for geometry inspections, that's like on the tail end, and I would say on the high end, right? So not a low end solution, but a higher end. There was a tool, if I'm not mistaken, that was out of South America that was called the Porcupine.
Yes, that's what I was thinking of.
Yeah, it was a Porcupine tool.
I wonder if it's still there.
And I think it's probably still in the market. And,
I haven't seen it in many years though.
And the way it operated is, imagine a bunch of bristles.
Yeah.
Right, like a porcupine, and it would navigate and do direct contact with the ID of the pipe, and it could detect a bunch of things.
Yeah.
So it had dual purpose. It wasn't just identifying geometry deformations, but if there was metal loss, there would be a response in the.
You're doing great.
Yeah.
You're losing your words. This is what vacation does to you. Too much sun on the beach and too much other things.
In the bristle. Right, in the pencil, whatever you want to call it, right? Anyways, and he and he was leaving pork chops. I mean, chopsticks.
Pork chops.
Chopsticks.
Pork chops. You
chopsticks,
just changed the name of.
Bunch of chopsticks running on the idea.
I'm gonna save us. I'm gonna save us. We're gonna take a break on this note, and Christopher's gonna go find out about pork chops or porcupines or whatever.
I'll get a snack.
Oh my gosh, we'll be right back. Take a break. Thank you.
Hi, I'm Kara Turner. I am the managing Managing Director and co-founder of ADV Marketing. We get the honor of working with Rhett and Christopher to produce this crazy podcast and also work with them on any other initiatives that they have when it comes to marketing. And if you know them or are listening to this podcast, you know that it gets pretty crazy around here. So we have a lot of fun with them. ADV Marketing is a full-service business-to-business marketing agency. We specialize in service companies and technology companies. So if you are enjoying listening to this podcast and the fun that they're having, reach out to us and see how we can make your marketing fun.
All right, welcome back to Pipeline Things. Chris is finding his place with some food. Did you just crinkle the wrapper on the air?
I took time to eat a snack. You know I'm a stress eater.
So the podcast is 30 minutes out of the day, and you have to eat in the podcast.
We're busy now. Right, there wasn't like episode 2 where we were trying to find things to do.
All right, I'm going to try and keep it real for that. Nobody wants to watch YouTube and see you munching down on that chocolate chip thing. I also want you to be able to remember your train of thought. So I don't want to stop you from eating.
Well, no, I'm getting all the sugar. We're good.
Okay.
Let's go.
That doesn't have sugar because you made me buy the protein bars that don't. I know darn good and well you're really picky about which protein bars I buy. So let's stay on the subject of tools.
Okay.
Right. So you mentioned the porcupine tool. That one's not too common, right?
Yep.
I think of the major tools on the market. We talked about some that are cup behind or sensors behind the cup. We talked about those, and there's a number of them that are like that, right?
Yep.
What are some of the other ones, Chris, that you want to keep the audience aware of, or you want to bring to the table?
So it's not very common that geometry tools are deployed by themselves, right? So it's not very frequent.
And I will agree with you. They are almost always, that's
It's
they're
some
the
form
middle
of
child.
combination, right?
They never get to be on their own. And EMATs run on its own. You'll see MFLs run on their own. You'll see ultrasonic wall thickness run on its own. Hell, I've even seen an IMU run on a cleaning pig on its own. But you're right. No, but I'm not bitter. Maybe this is why I get
Is the geometry tool the middle child?
It is the middle child. I see where you were going with it now. It's a bitter technology.
Anyway, so it's you can deploy them by themselves, but they're often not deployed by themselves.
Yeah, it's pretty rare. We know.
And so there's, often you'll see it as an MFL combo. That's pretty common now.
Heck, I've even seen the caliper put along just to drag the IMU. It's so bad. So
and those applications are very helpful, right? Because that's when you can look for real integrity threats, right? Like dents with metal loss. With the intent with dental metal loss is not a deformation with coincident corrosion, right? But rather third-party damage that you're looking for. And so some examples are like, for example, we know one technology out there owned by Rosen has an eddy current sensor on the head of the caliper unit, right? And that's really good for measuring standoff, and they can couple that with the direct contact to do real good profiles, right? Which goes back to your point on if you don't have the resolution, if the data isn't specific enough or characteristic enough, then maybe you're not getting the profile you need to do an integrity assessment.
Yeah.
Another application is, for example, we know TDW's MDS.
Yeah. Right? And they have, their sensor looks different. Like it's got the little knobby tight top. Mm-hmm. And to be honest, again, just speaking about my experiences, I've heard lots of good experiences with operators using that technology and specific types of threats to capture the profile. And so, even though it doesn't have a lift off or something else, does a really good job capturing that shape.
Yeah. And so not all caliper tools have lift off sensors, but they deploy other techniques, right? So like on the MDS, they have various forms of magnetic technologies. They bring them all together and they can still look for third-party damage and those type of things. So the point there is
it's a supporting technology.
It's in the middle.
It plays second fiddle.
It's in the middle of the drivetrain and the battery pack.
You made us go all the way down that thing just so you could reestablish
that you have middle child syndrome. Again, technically I'm a middle child, but we act very different.
Yeah, we act very differently in numerous ways. Like, for instance, I generally would not eat on the show out of respect from his producer in the audience.
Are you hungry? Would you like one?
I know where you can find it. A, she doesn't want to eat after you. No, I think actually you took the last chocolate chip cookie dough one.
This is you're good. This is chocolate chip cookie dough.
You left all of like the fudge brownie ones in there, and he took the chocolate chip ones. Just want you to know. So let's get into more common issues with geometry tools, right? Because I get a lot of these, and I'm sure you have too. And I think one of the most challenging things that I've seen, because it seems so easy.
Yeah.
Validating geometry tools.
Yeah.
I think offhand, most people feel like, it should be really easy. You measure the depth of a dent. Until you've tried to measure a dent in the field.
That's where tool tolerance comes into play, right? So we're normally better at that as an industry considering a unity plot, right? Which is often how we compare tool performance with what we find in the ditch, right? And for metal loss, we have really good tools like Creaform, which could also be used for deformation tools, all those fun things. And so, but when you look at tool tolerance for those things, it's kind of hard. Like, what are you verifying? The length of it? When you're doing a dent?
Well, they almost always want to look. Specs are written in terms of depth, whether I think that's right or not. They're written in terms of depth for dents, right? Like, so percent diameter.
But don't we want to know the sharpness of a dent based on strain?
Yeah, but there's nobody out there that's got a spec on strain for their tool, at least not that I've seen.
And so what we're getting to, right, is when you look at validation, it's really important to understand what component you're going to try to validate. So I'm going to go all the way back to what I mentioned earlier: POD, POI, and sizing. Right. So when you go through a validation of whatever technology it is, in this case maybe geometry tools for deformations, you need to ask yourself, what am I looking for and what's important?
So but I think again, because it's a middle child, because we've been here, done that before. I think most operators get out there, they're like, hey, you're looking for a dent, they find a dent. The challenge is, and we got this question, I would get it while I was a consultant, I got it while I was at Rosen. I measured the dent depth and you were way off.
So why is that, right? So let's think about the way that, let's pause for a minute, right? Let's see if you can see what I'm saying. You see what I'm saying? So you have these calipers, or even the cup, riding on the ID of the pipe. Normally there's going to be sufficient tension, right, on the caliper arm to where it's sensitive to movement but not too sensitive. And a performance spec will say we have a sizing of X depth with a plus or minus threshold. And that's normally calibrated to each tool. Why would they be off?
So, number one reason.
Because normally these are pretty tight tolerances. Often you can see like plus or minus 25% of OD, a 0.25%, like a quarter of a point of OD. So how could they be off? Man, that's pretty small.
Oh man, I don't want to go there.
Let's go.
I think the two most common reasons are whether or not the dent was restrained, bottom side. Is a common term we use, and potentially pressure. So I'd say, bar none, the most common reason why is operators go out to dig a bottom side dent. They dig the dent, they remove the restraint. It might have been a rock, might have been stiff soil, might have been an old, wooden support put underneath there. Could have been a sandbag, could have been any number of things. They remove that support, that really shallow 1.4% or even sometimes longer 2% dent pops back out, not necessarily with a loud noise, although I've heard the rumors of rifle shots, when dents reround. I know it does happen. It's not common, but it does. And then the dent is no longer there. Or it's there at such a lower level it would be well below reporting threshold. That's the most common reason. And that's hard for operators to understand. What I'd tell them is that there was a lot of research done on that. You can go find some older papers from Rosenfeld that relate the dent rerounding. Even Chris Alexander has some out there that relate the rerounded depth of the dent before and after the restraints moved. So that's the most common reason.
So I'm going to ask a couple questions, which we'll see. So we know you're pretty passionate, the difference between a wrinkle and a ripple.
Let's do it, man. Are you trying to make me? I have not. You walked off the set of the birthday episode off for like a joke. I've not walked off the set in anger yet. I could walk off a set in anger.
Is that typical for middle child?
Yeah, it is. It is. We had some emotional anger issues growing up.
So maybe we'll talk about ripples and wrinkles and ILI tools are able to do that in a minute. Let's focus on dents and deformations.
Let's do it.
Right. What's your thoughts on characterizing something as a deformation versus something like a dent? What do you think?
So I think you have to realize that the tool sees signals, right? It sees a signal pattern. They do the best they can to identify it. What I'll say is this. I've talked to a number of analysts, not just at Rosen, so I'm going to blanket it.
2 analysts.
No.
4.
Not just, no, more than that. That have never seen an actual dent in a pipeline. They call them. They've called thousands of them. They've never seen an actual dent in a pipeline. Ask them what a wrinkle is, and they couldn't tell you. Ask them what a wrinkle bend is, and they couldn't tell you. Ask them what a ripple is and what causes it, and they couldn't tell you. I mean, again, we've had this conversation, Chris.
So what are you saying?
I'm saying that analysts see signal patterns and they try and interpret them to the best of their ability. It's most common for them if they see a deformation to call it a dent. I think they know a little bit about when they see something that doesn't look like a dent, and they'll say, oh, that's a wrinkle. But to be honest, they will struggle with a deformation that may be an incipient buckle. I've seen buckles called dents all the time.
So
they're not easy to necessarily discriminate sometimes in the data.
That's
Is
a
that
challenge.
where we're going?
No, it's
Really?
not. I'll take you where we were going. For me, it's a valid point. You brought up something very, very real, which is, and I'll talk to the audience here, right? And this is the important of understanding your reporting requirements.
Yeah.
This is the important part of understanding a tool's capability, the ILI system's performance specification, the POD, POI, and sizing. More specifically, the POI side, right? Where you'll normally get a list of feature types at which to have a confidence. And normally those confidences are broken up through under 50%, between 50 and 90%, and equal to or greater than 90%.
Yeah.
And so an example of that would say, we can see dents or deformations at a greater than 90% confidence, right? But you would see maybe something like, what would we say? Buckles would possibly also be greater than 90%. What's something that you would say is probably less than 50% would maybe be, a light ovality as a deformation change?
You mean capability to identify it?
Yeah, identify.
Or capability to detect
Identify.
it? Okay, because I was saying,
right, so you'll get a
detection-wise-
signal,
Yes.
but being able to properly identify it, right? And so my point is, the highlight is that's what's important here. And so once you understand that as an operator, and you understand what ILI system you're deploying, if it's sensors behind the cup, high resolution, part of an MDS, part of a combo tool, has a proximity sensor on it, you're using it with MFL, whatever it may be, you really relate that back to their ability to use POI. And why is that important? Here's what I'm getting. I'm saying all that to say this, because that's going to help you drive your response.
Yeah.
That's going to help you engage with one ILI analyst one way and one ILI analyst another. So if one vendor's spec isn't very transparent or clear about what their POI capabilities are, and another one is, then you know where to drill in a little bit more and understand what's going on.
Yeah, I can see where you're going with that. I was thinking more along the lines of sometimes you have to integrate other data sets to really figure it out. So
that's a valid point too.
The example I had in mind is we had a particularly deep dent that was called, and when I got asked to look at it, I was like, hold on, bring that up.
Yeah.
And when I brought it up in a 3D render, so not in a color plot, not in a line plot, I was like, ew, that does not look like a dent. Yeah. Not unless something went perpendicular across the pipeline to it, which is possible, but I was like, it does not look like a dent.
Yeah.
And so I start digging around, and I'm like, wait. This is in a bend? Wait, this is on the inside, the compression side of it? I was like, guys, this is not a bend. This is a buckle. Like, this is 100% a buckle, and it all becomes clear.
Yeah.
When we got into that,
called in the log.
It was called as a dent.
Yeah.
It's called as a dent, 100%. And that's not, I have seen that multiple times, right? So I think it's particularly, and that doesn't even have to be particularly deep deformation for that to happen.
Yeah.
Point is that they see signal patterns and discriminate them. So I give you things to look for in the log that often don't get called. I've seen double dents, multi-peak dents, but those aren't always called on a consistent basis, right? Complex dents. I saw my favorite one. I had a buddy, and if he listens, he'll know dent with a tail. I was like, what is a dent with a tail?
So
what
an animal was like impressed into so the bone structure of the animal
we said,
the
look,
deformation.
it's the way of showing the fact that the dent doesn't taper back to nominal. It just kind of keeps going for a long time. So we had a good laugh about that.
That's funny.
But point is, you will often see things, and the only tag they have is deformation.
Yeah.
Right. You mentioned wrinkles and ripples. I've gotten into numerous conversations with analysts about that, right? Where they'll call something a wrinkle, and I go and look, and I'm like, well, how many of these do you see? They're like, well, I only see 3 of them in the line. I'm like, it's probably not a wrinkle. That's probably a ripple from, let's say, an uncontrolled bending process.
Yeah.
Right? When was it constructed? 1970. Yeah, it's not a wrinkle. Well, what's a wrinkle? A wrinkle is when we intentionally bent the pipeline in the 1940s and 50s, and those occur like in huge numbers very consistently across the pipeline. But that's not how the spec's defined.
So I'll ask you this question. So can all geometry tools find wrinkles, ripples, and buckles?
They will all find them very well. I'm going to say, well, the ones I've worked with.
Yeah.
They will find wrinkles, ripples, and buckles. I would say on wrinkles, since those are outward.
That's POD.
Yes, their detection capability.
Will all of them properly identify them as ripples, wrinkles, and buckles.
No. And more often than not, if you're a vendor and you get a wrinkle or a ripple, those two terms are thrown about interchangeably, both by vendors and analysts. Yep. In general, they will say, oh, well, a ripple is less severe than a wrinkle and a wrinkle is more severe. But that's also extremely subjective, and there's no hard line in the sand. Rather than interpreting them according to their integrity background, which is ripple, we didn't intend to get in the pipeline. Wrinkle, we actually intended to get in the pipeline.
Sizing, last one.
On wrinkles and ripples?
Yeah, buckles, wrinkles, and ripples.
Oh, man, that's a little bit of the Wild West, to be honest. I'd say that that's something you need to work closely with your vendor on.
Yeah.
If you have a true wrinkle problem, like wrinkle bends, I think you need to really work with a vendor to understand their sizing capabilities, how they're arriving at those sizing capabilities, and the confidence they have in them.
And what I guess I want to highlight...
But that's not just... I can't tell you, yes, it just works, or no, it doesn't.
And that was kind of a leading, ambiguous question, because that's where the sensor technology of the ILI system is really important, right? So if you think of the porcupine, if it can extend all the way through a wrinkle, then it would do a great job, right? To have all of these bristle brushes, creating the profile of it real nice, right? So if you're thinking about it, it's doing this, right? If you've got a sensor behind a cup, depending on the thickness of that cup, depending on the circumferential extent of that cup, it may not be able to go into the wrinkle, the buckle, or the ripple to kind of profile it. If you have a smaller, thinner sensor, that will have advantages and so forth. So the whole point is, depending on the threat you're trying to assess and how you're trying to characterize it, it's not just about a numerical analysis of POD, POI, and sizing, but you really want to lean in a bit and say, man, what's that sensor doing there?
How many geometry nerds do you think are following this conversation right now? You think we got some real pipeline geometry nerds? Or are there just a bunch of people like, oh God, he's talking about geometry tools. Middle child stuff, move on.
It goes on the back of an MFL. Move on. When are y'all going to talk about MFLC?
Let's jump on sizing for a moment, because you mentioned sizing ripples. Let's go back to sizing and dents, because this is a question I get all the time. Rhett, I ran. That was the title of the paper. Largely misunderstood. It was not that it was "Judge me by my size, do you?" and it was a Yoda quote. You can go look that up at IPC. Sticking on that subject, but sizing just in regular deformations. Yeah. Common question I get is, Rhett, I ran a geometry tool, and dents that appeared in the previous inspection disappeared in this inspection, or vice versa.
Yep.
And when they're right around
we all know what happened there.
I see it all the time.
Know what happened.
Well, but it's deeper than that. Here's what I will say, because I wanted to offer a little bit of advice. Understand how your vendor is reporting depth.
Yep.
Right? 'Cause you say it like it's so simple, Chris,
but
it's not. No, look, I was in 1183, and when we got in a discussion on how to define dent depth, dude, it's not uniform. And Rosen was not the only vendor in that room. There were other vendors. Like, is dent depth total bore restriction? Is it just the dent portion? Is it dent plus ovality? Is it dent minus ovality? I will say, you need to talk to your vendor to understand what that dent depth they report to you mean. And I'm going to go another step further. It may not line up with how dent depth is, let's say, understood in something like 1183, or maybe even understood in terms of regulatory. I'm just going to leave that out there, because you're acting like, dude, it's dent depth. It's dent depth. I'm like, oh, really? Is it with or without ovality? Is it just the dent portion? So if I have a pipe that's got really, really long dent, do I just take that little 6-inch part that's going to match up with the field?
You're really passionate about this.
Because it's not easy. Yeah. And if you have one vendor...
Do you have a dent that you just kind of like rub on every now and again?
Do you want to see my tattoo? No, it's on my back.
You're pretty.
It's on my back.
Is
right
it a
here.
caliper tool?
Yeah, no, it's a
middle child. So I'll say this. I think that's a really good segue for the next show. Yeah. I really do. I think we've talked about different caliper tools.
Are you ending it?
No, but I think we've gotten to a really good spot.
No, I agree. I think where we need to pick up, and where we're going to take the audience next time, is understand what you're getting. We're going to jump into radii files, what those mean. You know how annoying that probably is to everybody that's listening when you crunch the paper like that?
These are really good.
Because like one of the things you can do, like if you want the audience to know you're done with something, you just crumple the paper.
Are you done
and
with
throw
this
it
podcast? Is that what you're trying to say?
You know what? We're going to be back with radii files. We're going to be back with more on geometry tools, 1183, dent assessments, all that and more on our next episode. Thank you for joining us this time on this middle child journey as we talk about geometry tools. We'll see you in 2 weeks. I'm your host, Thing20, and my co-host, Thing21. Thank you for joining us.